Hi everyone, this is Regularization. Today we are going to dive into an important concept in machine learning and deep learning, which is regularization. If you ever face the issue where your model performs great on training data but fails on nuancing data, you are on the right place. Let's begin with the common problem, which is overfitting. Overfitting is a problem when a model learns the training data too well, including its noise and outliers. As you can see that where the model is learned or draw hyperplane perfectly. So as a result, we get higher accuracy on trained data, but lower accuracy on test data. In the other case, like this model is unable to capture the underlying pattern, thus we get worse performance on both training data and test data. But our model should be fit like this. That's why we get higher accuracy on both training data and test data. What is regularization? Regularization is a technique to reduce overfitting. So if we just simply just training data, just training a model, so here there might be chances to overfitting. So that's why we get performance. But if we use regularization, so then our model should be more robust and simple, and we will get the best performance. So there are several types of regulation techniques among them, L1 regulation, L2 regulation. This type of regulation is used on traditional machine learning algorithm and dropout and early stopping, which is highly used in deep learning techniques. So let's dive deeper into L1 and L2 regulation techniques. L1 regulation technique, also called Lasso, where it's a penalty equal to absolute value of the weights. So in that case, just we simply add a penalty term with the loss function, and here alpha term indicates that hyperparameter. And in case of L2 regulation, which is also known as Reed regulation, it's the square of the weights up to the cost. Unlike L1, it doesn't zero them out; it just makes them smaller. So and now this is the visualization of L1 and L2 regulation technique. As you can see that in L1 regulation technique, some weights it's close to zero. That's why it increases the sparsity. But in case of L2 regulation technique, it can't bring them zero, but it's able to, or it is responsible to make the weight too smaller. Now let's dive into dropout, uh, which is helpful when we just training our model by using deep learning technique. That's time. Basically, dropout is a powerful technique. During training, it's randomly turned off some neurons. As you can see that here, four neurons are available, but in that case, two neurons are just randomly just dropped. This prevents the model from relying too much certain parts. So let's dive into the next topic, which is early stopping. So in this time, we have to monitor the training loss and validation loss. When training loss is keep going down and validation loss is also keep going down. So that time our model is continuously training. But when the validation loss is increasing, but training loss is decreasing. This time we should stop our training process. This is called early stopping. So that's all about my presentation. Thank you.